All right, time for lesson 12. We're going to continue to practice graphing on the coordinate plane today. I really like this lesson, so let's dive into it. The first thing I need to kind of say about this first activity is, you know how when I print out these activities, they don't always get everything we need. So there is another graph for part number 1 on this activity. So I'm going to have to flip to that when we get there, but we'll deal with that when we get there. Okay, so let's look at what we have here. The following data were collected over one December afternoon in England. Okay, so this is in England. Time afternoon. So 0 must be noon, right? And then 1 p.m., 2 p.m., 3 p.m., all the way down to 8 p.m. Does that make sense to everybody? And then over here we have our temperature in degrees Celsius, because that's what they use in England. So we've got 5 degrees, 3 degrees, all the way down. Later in the day, it got colder and colder, all the way down to -4 degrees Celsius. Okay, so that's the data that was collected, the weather data. Now in number 1, it says, which set of axes would you use to represent these data? So if I were to plot all these points on the graph, which one of these 3 graphs, again, that's why we need this third one, which one of these 3 would be the best? Right? That's the question here. Okay? So that's what we have to decide. So let's look at all 3 of these. Notice how different they are. The boxes are different sizes. Things are quite different in each of these. And we need to decide what we like and what we don't like about each of them. Okay? So let's look at graph A first. Graph A, we have our time, afternoon, and hours on the bottom here. So as long as we can get all this data in there, we should be able to go from noon to 8 p.m. Can I go from noon to 8 p.m.? Yes, that'll all fit in there. So yeah, this axis will work. Let's check the temperature. The temperature axis in part A is this one right here. And I need to be able to go from a +5 all the way down to a -4. So looking at this axis here, I can go up to +5, no problem. But can I go to -4? That's a problem. Look how many data points I wouldn't even be able to graph on this axis. Okay, so that's no good. We can't graph all of our data, so I can't use that coordinate grid at all. That's no good for what we need. Okay, let's look at graph B. Graph B, now we have positive and negative, so it looks like that problem got solved. Let's make sure we can get everything on there. Can I get from noon? I'm going to actually write that on there to remind me. That's noon. The 0 hour is noon. All the way up to 8 p.m. Can I get all of that data on here? Well, here's my timeline. From 0, 2 o'clock, 4 o'clock, 6 o'clock, 8 o'clock p.m. Yes, I can. Notice it gets a little squishy, so they only labeled every other one. Is that okay? Yeah, absolutely. It actually makes it really easy to read, doesn't it? So yeah, the time axis is perfect. Let's check the temperature axis. Can I go from +5 to -4? Well, there's +5, so yes, that works. I can get all of those in there. Can I get all the way down to -4? Yep. So far, I can get all my data onto this graph. I'm thinking B is a good choice. But let's see if C is an even better choice. Let's move over here to C. Notice they've given us really big grid lines for this one, which is really nice. The bigger they are, kind of the easier they are, right? But there's one thing I don't know about here. Again, I need to get my data from noon to 8 p.m. So if I look at time here, here's noon, and this is already 10 p.m. 20 p.m.? That doesn't even make sense. 30 p.m.? Does that make sense for time and hours? 40 p.m.? That doesn't even make sense. It only goes to 12 p.m., right? Even if we use a 24-hour clock, it would stop right there. We don't need 30 or 40. So that axis doesn't even make much sense. Besides the fact that all my data would be squished into here, wouldn't it? It'd all be really squished. Between 5 and -4 would be really, well, no, between 0 and 8, I guess, the time. I was thinking the other way around. Time would be all squished into this one box, wouldn't it? Let's look at the temperature one, the up and down. Again, we need to go from 5 to -4. So from +5, yeah, that works, to -4. But see how we're only using that much of the graph when we have all this? So we're only using this teeny little piece right here. And all this space out here, well, it's nice to have. It's kind of a waste, and it actually makes it harder because this is so squishy now. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 points I have to graph in this teeny little area right here. So I don't think C is a very good idea at all, which means that we were right. B is the better choice. B is a great axis, a great coordinate grid for our data. Okay? So which set of axes would I choose? I would choose graph B. Explain why. Well, it gives us everything we need, right? It's got good organization. It's got a good size grid. We can definitely find what we need. And it gives us the range we need to get all of our data nice and spread out without having too much, right? So you can explain that in your own words, okay? Let's move on to number 2. Number 2 on this one actually asks us to explain why the other 2 axes did not seem as appropriate as the one we chose. So why was A no good? Well, A didn't have negative temperatures, right? That was a deal breaker for that one. Without negative temperatures, we couldn't even graph. Remember that? We couldn't even graph some of our data because we didn't have negative points on our grid. Okay? So why was C not a good choice? Well, because it was too big, right? And because time didn't make sense. Time equals 40 hours doesn't make sense. Right? If I can spell. So you guys aren't the only ones that can't spell. I can't spell either. Okay? Plus, it's just too big. I'm just going to write too big. Right? It just would squish things too much. Okay? Awesome. Moving on to activity number 2. Now, in activity number 2, we have a blank grid, and they ask us, here are 3 sets of coordinates. Well, they're talking about A's set, B's set, and C's set. That's what they mean by 3 sets. Okay, so we'll get to those one by one. So there's 3 sets of coordinates. For each set, draw and label appropriate pair of axes and plot the points. Okay, so that's what we're going to do today. We're going to draw our own graph, decide how we're going to make our axes so that we can get all of our coordinate points onto our graph. Okay, now I'm going to use this little ruler guy here today just so that my work is nice and neat, but you do not have to use a ruler. Okay, I don't want you to think that just because I'm using it, you have to. It's just for the purposes of this video. I want it to be nice and neat, but you can do what you would like, whatever you have. Okay, let's take a look at our data points here. The first thing I do when I have a bunch of ordered pairs is I focus, just like we did with this table, focus on one of the coordinates at a time, right? These are the x coordinates and these are the y coordinates. So we just want to focus on one at a time, okay? So let's focus on the x coordinates. For my x-axis, which is my horizontal axis, I need to be able to plot a 1, a 3, a -5, and a 0. So really the range of those numbers is not very big. Could I count by 1s on this grid thing? Yes, because they'll all fit, won't they? We got plenty of room left to right to fit from -5 to up to +3. So left to right is not going to be a big deal. Let's check out our y coordinates. I'm going to put arrows to our y coordinates. We have to have a +2, a -4, a -2, and a 2.5. Now that decimal might make it a little tricky, but 0.5 isn't bad. We know that's halfway between 2 whole numbers, so that won't be bad. So I need to go as low as -4 and as high as really 3, right? Because 2.5 is, I need to have something to do a reference to that. So I need to go as high as 3 and as low as -4. So for my axes, I know I have to go lower than I have to go high. So I'm going to move my horizontal axis up a little bit. See, and my ruler isn't even quite long enough for this graph, but that's okay. But I'm going to use it anyway. Okay, so here's my horizontal axis. And I chose to put it right here, just slightly higher than center, because I know I have to go down more than I have to go up. Okay, so there's my horizontal axis. And then for my vertical axis, remember on this axis, I have to be able to go from 1, 3, -5. I do have to have a -5 over here. So let's make sure if I have -5, say here, I need to make sure I put my y-axis in the right spot. So let's count. -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. See, and I had plenty for what I needed, didn't I? Now I know where my 0 is, so I'm going to draw my vertical axis now, right through 0. Put my arrows on it as well. Okay, so now I have my graph drawn. I do need to label my axes. -1, -2, -3, -4. Now we're ready to go. Let's plot these points. My first point is at 1, 2. So to the right 1, up 2. There's my first point. It says draw and label, so I'm going to label that 1, 2. And then my next point is 3, -4, so I'm going to go positive 1, 2, 3, and then down 1, 2, 3, 4. So there's my next point at 3, -4. My next one is at -5, -2, so I'm going to go to -1, 2, 3, 4, 5, and -1, 2. -5, -2. Okay, my parentheses are looking ski-wumpy. My last one is at 0, 2.5. So 0 means I don't go left and right at all, but I do go up 1, 2.5. So we're going to be right on the y-axis at 0, 2.5. Okay, so now I have graphed all 4 points, 1, 2, 3, 4, or 1, 2, 3, 4. It's nice and spaced out and looks really, really great. Okay, awesome job on graph number 1. Let's move on to graph number 2, or part B, I guess we should say, part B. Ooh, look at those numbers, very different numbers. Instead of having 1s, 2s, 3s, I have 50s, 30s, 10s, 35s, 40s, much bigger numbers. Am I going to be able to count all the way up to 50? Absolutely not. So we're going to have to make each box worth more than 1 unit, aren't we? We're going to have to count by what? What do you think we're going to want to count by? Well, I would say at least 5s, if not 10s. Do you think we should count by 10s? I think we might have to, right? On the x-axis, I've got to go from positive 50, 0, -10, -35. So from 50 to -35. I think I should go by 10s. And then on the y-axis, I've got to go from 50, 0, -30, and 40. So from 50 again to -30 is my lowest. So yeah, I think I better go by 10s. But I think we could center this up pretty good because they both go to 50 and they both go to -30 something, right? So I think if we just center this up, we should be pretty safe. So let's just do it right down the center this time and see how it works for us. So there's my y-axis right down the center and my x-axis. Let's try it right in the center and see how it looks. Put the arrows on the end. Putting the arrows on the end really make that line stand out a little bit more. Okay, now we need to label this. Because these are such different numbers, we need to make sure we tell our audience this is actually 10, 20, 30, 40, 50, 60. This is actually negative 10, negative 20, negative 30, negative 40, negative 50. This is negative 10, negative 20, negative 30, etc., etc. And this is a positive 10, 20, 30, 40, 50. By the way, it does not matter what side of the line you label. There really is no rule about that. So it's just wherever you feel like you have the most room. So just for your information's sake. All right, I think we forgot to label 0. The origin is always labeled 0 or O. Okay, 50, 50 is my first point. So I'm going to go positive 10, 20, 30, 40, 50, and then positive 10, 20, 30, 40, 50. There's my first data point at 50, 50. Okay, done. Second one is right at 0, 0, right at the origin. So I'm going to put a nice big point at 0, 0. There's my next point. And then I have one at negative 10, negative 30. So negative 10, negative 30. Negative 10, negative 30. Done with that one. Now, negative 35 and 40. So I'm going to go to negative 10, 20, 30. But then 35 is halfway between 30 and 40. So there's negative 35. But then I have to go up to 10, 20, 30, 40. So there's where my dot for negative 35, 40. And now I have 1, 2, 3, 4 dots, so I got them all. That was a really good spacing out. That was a great grid that we chose for that one. All right, graph C now. Look how different our data is on graph C. They're all fractions. So are we gonna wanna count by tens this time? Absolutely not. That would be way too big, right? Really a bad scale. What do we wanna count by on this one? Let's take a look at our data. 1/4, 3/4, negative 5/4. In fact, I notice most of these are fourths. And these that are halves, could we change them to fourths? Yeah, 1/2 is actually 2/4. Negative 1/2 is negative 2/4. So if everything is in fourths, now, it would be really handy if each grid mark was in fourths. What do you think? I think that's a great idea. And they're all really close to 0 or really close to 1. So I think we could center this up and it would be a great grid if we just center it and then make each grid worth a fourth. Let's try that. So there's our y-axis. And then my x-axis is going to be right in the middle as well. Put my arrows on that. Wow, I just bumped my camera. Sorry about that. All right, so I've got my axes drawn, but I do need to label them up, especially because they're fractional. So let's label. I don't think I want to label every single line. Let's just label 2/4. Well, how should we do this? Maybe I should label every one of them. 1/4, 2/4, 3/4. Maybe just that far. That kind of tells people what our scale is. Yeah. And I'm doing everything in fourths. Whoops. Because, oh my gosh, I keep writing fifths instead of fourths. Crazy. 5/4, 6/4. Just to make it easier for myself, now for the negatives. Negative 1/4, negative 2/4, negative 3/4. And negative 1/4, negative 1, oops, 2/4, negative 3/4, negative 4/4, and negative 5/4. It's got kind of sloppy there, sorry about that. And of course, 0 in the middle. Okay, now it's time to graph these, plot these points. 1/4, 3/4. So I'm gonna go to positive 1/4 and then up to 1, 2, 3/4. So there's my first ordered pair, 1/4, comma, 3/4. Next is negative 5/4. So negative 1, 2, 3, 4, 5/4. And negative, no, I'm right here. And positive 1/2, which we know is 2/4. So 1, 2/4 is right there. So this is negative 5/4, comma, well, I'm going to write 1/2 because that was what the original value was. Okay? Now for our next one. So we've done that one, we've done that one. Now for this one. Now, negative 1 and 1/4 is the same thing as negative 5/4, right? Because that's 4 and 5/4. So negative 5/4. So I'm going to go to negative 5/4 and then a negative 3/4. So negative 1, 2, 3/4 is right there. So negative 1 and 1/4, comma, negative 3/4. Don't want to forget my parentheses. Okay, there's that one. My last one is 1/4, negative 2/4. So I'm going to go again to positive 1/4 and then down to negative 2/4. So it's right there. So 1/4, comma, negative 1/2. Okay, now I have my 4 points graphed for part C. Great looking graphs. We did it. I hope yours look as good as these ones do. I'm sure they do. Well done. Now, number 2 is kind of a discussion problem, but I would like you to write down, at least jot down some of your answers to this, because discussion really doesn't happen at home, does it? So write down or explain some of the answers that you came up with for this question. How are the axes and labels of your 3 drawings different? So maybe you and your partner drew these slightly different. The idea is, how could they be different? Well, maybe, like for number 1, we off-centered this slightly. Did we have to? No, right? Maybe your partner did it slightly different. But how is it different from all 3? That's kind of what I want to talk about, is how are all 3 of our graphs different from each other, right? Well, in this one we counted by whole numbers. In this one we counted by tens. And this one we counted by 1/4. So that's a big difference. So I'm going to write down that for this one. Counted by wholes, by tens, and by 1/4. That's very different, isn't it? Okay. How did the coordinates affect the way you drew the axes? Well, that's what helped us make those decisions, right? How did these coordinates here help us draw our graph? Well, they're exactly what helped us make those decisions, right? These fractions are what made us decide to draw it as fractions. These big numbers are what told us to count by tens, right? So the coordinates themselves are what helped us make the decisions. They helped us make decisions about scale, what it's called. In other words, how big or small to draw it. Okay, so that's what I'm going to write for number 2. Okay, ready for activity number 3. And I really like this one too. It's got a maze. Let's read the instructions. It says, here is a maze on a coordinate plane. The black point in the center is 0, 0. Okay, so there's 0, 0 right there. Now, they did not draw the axes on this. Okay, you do not have to do this. On this first example, I'm going to go ahead and add some axes on there, just so that we have them as a reference point. We don't actually need them, but I think for explanation's sake, for right now, I'm going to add them in. And I'm going to make that line longer than even my ruler was at first, just so that we can see it. So there's the y-axis drawn in. Now I need my x-axis drawn in, right through that center origin point. Okay, so now we have our axes. So now it's kind of like a coordinate plane. Okay, Now, the next thing it says is the side of each grid square is 2 units long. So while they didn't label these axes because they didn't even have them drawn in, it's telling you that each grid is 2 units long. So this is 2, 4, 6, 8, 10, 12, right? Every single one of these counts by 2s. So that is super important to understand before we can answer these questions. Okay, now of course my questions are going to be on the next page. So I'm going to bring these over and we'll have to kind of share the space here. Number 1, it says enter the above maze at the location marked with a green segment. Now I printed these out black and white, so the green segment didn't show up. But in your workbook, it should be green. If you had to print them out too, I went ahead and before we started this, I labeled this with a green line. This little line right here was actually green. It should be green in your workbook, and that's where we're gonna start. This is where we're gonna enter the maze, okay? So that's the green segment it was talking about. Draw line segments to show your way through and out of the maze. So let's find the out. Where is the out of this maze? The only other break in the outside edge of this maze is right here. So I wanna go out right there. In fact, I'm gonna grab my handy green pen and I'm gonna make that arrow green so I know exactly where I wanna go. I wanna go out right there, okay? So we need to make our way through this maze, but it says we have to draw line segments. So no curvy wurvies, we're drawing straight lines, right? Straight line segments. So let's do this. Now, by the way, our axes are not barriers, right? So my pencil marks don't stop us. Only the black lines stop us, right? Which is one of the reasons they didn't draw the axes, okay? Okay, so let's see if we can make our way through this maze. I think we should go all the way. This looks like just not a way around, right? So I'm gonna go past that and over to here. I think I'm gonna go all the way to this point for my first line segment. But then I am gonna go turn. I'm trying to head down here, right? So I'm gonna turn and go down now. Let's see, I can't go very far. I'm gonna have to go down and around here, aren't I? So let's go down. I don't know if I need a ruler for this little teeny segment. I'm gonna go down right there. And then I'm gonna go straight across over to here. Now, one thing is that I do want to stay in the center of these boxes, right? Because I don't want to have to deal with decimals. You'll see what I mean in just a bit. And then let's see, where am I going to have to go? I think in my head, I found my way out. I'm just going to keep going. See if I can get out of this maze. I think I'm going to go clear to there. There's my next dot. And then I'm going to go clear over to here. Again, that's not a real boundary. That's just my axis line. And then up and over and out. Very good. I made it out. Did you make it out? Now, there may be more than one way to get out of the maze. I'm not saying this is the only way out of the maze. That's how I chose to go. So as long as you got out of the maze, you're good, right? There's no right or wrong way to get out of a maze, okay? Now, but we're not done yet. So we got all the way out of our maze using line segments. It says label each turning point with a letter. Okay, so we have to go through now and label all these dots we made. So I'm going to label them A. I'm just going to go from alphabetical order. B, C, D, E, F, G, H, I, J, and I'm going to do this last one over here, K. I did make a point there too. Did I miss any? I don't think I did. So you may have fewer or you may have more dots to label, depending on how you went through the maze, okay? Then it says to list all the letters and write their coordinates. Okay, here we go. So point A. Let's look at our graph here. It gives us some hints. This point right here is at -10, -14. So just like it said earlier, each of these is 2. So 2, 4, 6, 8, 10. That completely makes sense. So let's see, where is point A? Well, if that's 10, this must be halfway between 10 and 11, or 10 and 12, so that must be 11. So A is at negative 11, comma, how far up do I have to go? Well, 2, 4, 6, 8, plus halfway to 10 is 9. So 11, 9 is my coordinate for point A. Okay, how about point B? Well, point B is right here. So from 0, 0, I have to go negative 2, 4, 6, 7, negative 7, and then up 2, 4, 6, 8, 9. 9. Okay, point C. Point C is right here. So from 0, 0, I have to go negative 2, 4, 6, 7. Oops, I went, that was the parenthesis the wrong direction. So negative 7, comma, 2, 4, 5. Okay, so negative 7, 5 for C. D is over here now. So now I'm going positive, but it's not all the way to 2, right? Because again, we're in the center of the boxes. So just 1 is my first x coordinate, and then up to 2, 4, 5. So D is at 1, 5. E is at 1, and then 2, 3. Okay, so there's my E. Now my F. Again, your points may be different, but this is the process, right? So don't necessarily copy mine just to copy mine. If you did your own maze, spend the time while I'm going through these. Spend your time going through yours and checking each of yours, right? F is at 2, 4, 6, 7, and then up 2, 3. Okay, now G. G is clear down here. So this is 2, 4, 6, 7, 2, 4, 6, 8, 9. So 7, negative 9, because we went down 9, didn't we? 2, 4, 6, 8, negative 9. For G. H. H is at negative 1. See that? Negative 1 is my x coordinate. And then I have to go down 2, 4, 6, 8, 9. Negative 9 down. Awesome. Now I is also at negative 1, but it's only down 2, 4, 5. Negative 5. J. J is over here, so I have to go to negative 2, 4, 5, negative 5, and then negative 2, 4, 5. That's also negative 5. Now I need one more point, K, so I'm going to squeeze it in over here. Point K is actually out of my maze, kind of like A was out of the maze, but that's okay, that's perfect, that's fine. So we have negative 2, 4, 5, negative 5. And then all the way down to negative 2, 4, 6, 8, 10, 12, 14, 15, negative 15. There we go. We just finished number 1. How did you do? Did you get all your points labeled up and graphed on your maze? That was kind of fun. I like that. Number 2. Choose any 2 turning points that share the same line segment. What is the same about their coordinates? Explain why they share that feature. Well, all it's saying is here is we need to pick 2 points that are on the same line. So like C and D are on the same line, E and F are on the same line, F and G are on the same line. So we just get to pick any one we want. Let's do F and G. F and G. Okay, so I picked my two turning points, as they call them. What is the same about their coordinates? Well, if we go back up here, F was 7, 3, and G was 7, negative 9. So what's the same about those 2 points? The 7. Well, that makes sense. The x-coordinate has to be the same because they're on a vertical line. So the x-coordinates are the same. And it's because it's a vertical line. Okay. Now, if I were to pick, for example, C and D, what would they have had in common? Well, here's C and D right on top of each other. Look, they have the 5s in common. They have the y and the y coordinates the same. So horizontal lines have the same y coordinate. We went up 5 for both of those, right? So depending on which line segment you chose, your reason will be very similar to mine. And guess what, ladies and gentlemen? That's the end of the lesson. The Are You Ready for More, once again, is optional. Honor students, I would love you to tackle that one because you are very capable at doing that. And then, of course, you have your lesson summary to read through and study as needed. Followed by, of course, oh, that's still summary, followed by, of course, the practice problems. We'll dive into those next, but first, go make sure you have finished all your practice problems. Give it your very, very best shot before checking it with me in just a minute. Goodbye for now, and as always,
do your best, because you deserve your best.
Alrighty, here we go. We're going to go ahead and grade this homework assignment, practice problems for lesson 12. Let's dive in. For number 1, it says to draw and label an appropriate pair of axes and plot these points. Now, looking at these points, they're all fractions. So let's make a graph that makes that easier, okay? Now, I'm going to use my ruler again. You did not have to use a ruler. It just helps make straight lines, of course, right? So if you did, great. If you didn't, that's okay too. Just try to be as neat as you can. Straight lines are certainly easier to follow than crooked squiggly lines, right? So I'm going to make my axis here. There's my y-axis and my x-axis. And I'm just going to do that right in the middle here. I don't think I'm going to have a problem. I don't think I need to, skew it any one direction or the other. So I'm just going to do pretty regular axis here. Oh, I did actually not go in the middle, but that should be okay. Now, looking at my ordered pair, my ordered pairs here, 1/5, 4/5, -3/5, 2/5, everything is in fifths. So what if I make each tick mark a fifth? That makes sense, doesn't it? So 1/5, 2/5, 3/5, 4/5, 5/5 is going to be one whole. Do I need to go bigger than that? It looks like I will need to go bigger than that in the negative direction, won't I? So I'm going to go ahead and go one more in this direction too, so that they're the same. -1/5, -2/5, -3/5, -4/5, -5/5. Maybe I'm going to have to make this a little bit longer because I am going to need a -6/5, aren't I? Or -1 1/5. See, so we're adapting now. So I'm going to have a -1 1/5 over there. Actually, I'm going to, instead of labeling that one, I'm just going to label -1/5, 2/5, 3/5, 4/5, 5/5. That's a -1 right there. So I'm just going to label that. And then in the positive direction, the y direction, right, I need to at least get up to 4/5, don't I? So 1/5, 2/5, 3/5, 4/5, that should work. So I'm going to label that as 4/5. And then in the negative direction, I have to get down to -4/5. See, this is why I should have gone more centered because it would have been better, but that's okay. -1/5, 2/5, 3/5, 4/5. I've got room here to do a -1. You know what? I'm going to make this bigger. I'm going to get -1 in there, or a +1 in there. I'm going to make it a little bit taller so that I have +1 there. And then we know that that'll be 4/5, won't it? So that's really all I need to label, because I will know now that if this is one whole, it's split into fifths. Okay, then each of them is a fifth, right? Don't want to forget to label my origin. Okay, time to graph these points. 1/5, 4/5. So I'm going to go to positive 1/5 and then up to positive 1, 2, 3, 4/5. And I don't want to forget to label those 1/5 and 4/5. Okay. Next one is a negative 3/5. So negative 1, 2, 3/5. And positive 2/5. So up 1, 2/5. So negative 3/5, comma 2/5 is that point right there. Done and done. Third point is negative 6/5, right? Because this is 5/5 plus one more. So that's negative 6/5. So negative 1, 2, 3, 4, 5, 6/5. And now a negative 4/5. So down 1, 2, 3, 4/5. Kind of eyeballing here with the side. Negative 4/5. By the way, you do not have to draw every single grid line like you see on graph paper, right? You don't have to draw every single grid line. Just those that axes are really all we need. Don't make it all muddy and gross, okay? So this point is at negative 1 and 1/5, comma, negative 4/5. Done. Last one is at positive 1/5. Negative 1, 2, 3/5. So there's our last one, 1/5, comma, negative 3/5. And there we go. All 4 points graphed, done with number 1. How did you do? Did you get those all correct? I hope so. Good, number 2 now. Diego was asked to plot these points. Negative 50, 0, 150, 100, 200, 100, 3. Oh, wow, these are really big numbers, aren't they? What interval could he use for each axis? In other words, what scale should we use, or what should we count by? Do we want to count by ones? Absolutely not. I don't want to count up to 350, right? So we're definitely not going to count by ones. Even tens would be a lot, because that would be 35. What do you think we should count by here? I think we should count by 50s. All of these either end in 50 or end in something that would have an easy 50 to count, right? So I think we should count by 50s. By 50s. Because they're easy to count. And all data would hit the grid, right? 50, 0, yeah, those would hit corners, right? Perfect corners. We wouldn't have to guess, right? Does that kind of make sense to everybody? That's an important thing to think about, is getting them to hit right on the corners of the grid marks is super handy. I'm looking around for an empty coordinate grid. The only one I have is for our next lesson, right? We want them to hit corners here. We don't want to have to muddle the center of boxes. That just gets, kind of hard, right? So it's really nice when they hit the corners of the grid marks, okay? Number 3 now. Name 4 points that would form a square with the origin at its center. Okay, so let's think about what this would have to look at. And part B, if we look ahead, it tells us to graph these points and check to see if they're a square. So let's just do both of them at the same time here. Let's draw ourselves a little coordinate graph. It doesn't have to be very big. Okay, so I'm just going to draw myself a nice little coordinate grid, put my arrows on there. Now, we get to pick our 4 points, so it doesn't really matter what numbers we choose. Let's just say this is 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Now, to make this a square, all the sides have to be the same. And the origin has to be in the middle of my square, right? So, what if I were to go up 2 and make that line right there one of my sides? What would I have to do this direction? Well, I'd have to go over 2, because that distance would have to be the same, right? Same on this side. This distance would have to be the same, and so would this distance. Those would all have to be 2's. Now, is that square? Well, it doesn't really look square on my picture, but it actually is square. So let me finish drawing this. I was going to use my ruler, but maybe I'll just eyeball it. And I think it doesn't look square because my tick marks are not actually perfect. Does that make sense to everybody? But let's count my sides. How long is each side? Well, the top is 1, 2, 3, 4 units long. How long is this side? Well, it's 1, 2, 3, 4 units long. The bottom, well, that's going to be the same as the top, 1, 2, 3, 4 units long. And the side, yep, 1, 2, 3, 4. So it is actually a square, okay? So we need 4 points that would form the square. In other words, we need our 4 corners. So we need the ordered pairs for those 4 corners, okay? So let's list them. Let's start right here. This one is at 2. Now these 4s are not really this. That gets confusing because those are the side lengths, right? This is actually 1, 2, right? So this is at 2, 2. This one down here is at 2, negative 2. This one over here is at negative 2, negative 2. Wow, do you see a pattern here? And our last one, which is going to be squishy over here, is at negative 2, positive 2. Ooh, what did we notice about those? That's very interesting. 2, 2, 2, negative 2, negative 2, negative 2, and negative 2, positive 2. So all 2's, 2 positives, 1 negative, 2 negatives, 1 negative. But the other one is negative. Oh, that's cool. So we checked it. Is it form a square? Yes, we already checked it. All the sides were 4, so we checked it. Good job. Now, did we have to do a 4x4 square? No. You could have done whatever size square you wanted. But again, that process should be the same on how you check it. And the pattern we see in all 4 of those points should match the pattern, shouldn't it? Very, very good. Number 4. Which of the following changes would you represent using a negative number? Explain what a positive number would represent in that situation. Okay, so which one of these would make a negative number? Part A, a loss of 4 points. Well, there's our keyword there, loss. Yep, that's definitely going to be a negative 4, so A is a yes. So explain what a positive number would represent in this situation. Well, if a loss of 4 points gave us a negative 4, then a gain of 4 points, right, would give us a positive 4, right? Okay, let's check part B, a gain of 50 yards. A gain, well, gain does not mean negative, doesn't it? So no, B is out. Because gain is not negative. Oh, there's the word loss again. A loss of $10. If I lost $10, I'm definitely down $10, aren't I? Okay. So how would I get a positive $10? Well, I'd have to receive, right? I'd have to receive. I need a dollar sign in there. Receive $10. Okay, last one. Oh, I needed to circle C. D, an elevation above sea level. Is above going to be negative? Definitely not. So nope, D is out. So the answers to number 4 are A and C. And then I've got my good explanations there. Okay? Very, very good on number 4. Number 5 is next. Jada is buying a notebook for school. The cost of each notebook is $1.75. Write an equation that shows the cost of Jada's notebooks, C, in terms of the number of notebooks, N, that she buys. So we want to know the cost, right, in terms of or in equal to, okay, the cost compared to the number of books she buys. Well, aren't they $1.75 each? So wouldn't this be 1.75 times the number of books she buys? If she buys 3s, then I'm going to have to multiply that by $1.75. If she buys 10, I'm going to have to multiply that by $1.75. Does that make sense? So there's my equation. Okay? The cost in terms of $1.75 per notebook, N per being multiplying, right? That makes sense to me. Very, very good. Part B, which of the following could be points on the graph of your equation? Ooh, so if we were going to graph our equation, our ordered pairs would be N comma C, right? So if I plug in the first number for N, would I get C out of it? Does that make sense? So if I plug in $1.75 for N, or 1.75 for N, times it by 1.75, would I get 1? That doesn't make sense to me. No. I think they did that one backwards, didn't they? If N was 1, 1 times 1.75 would equal 1.75. But that's backwards. They had the variables backwards. Because this is the order we want, right? Let's try this one. This time N is 2. If I buy 2, would they cost $3.50? 175 times 2? Yeah, that's $3.50. So yes, that one's a yes. All right, let's check this one. If I buy 5, would it cost $8.75? Well, this one I don't know in my head, so let's check it. 1.75 times 8? No, times 5. Sorry, I looked at the wrong number. 5 times 8 is 40. 7 times 8 is 56. 57, 58, 59. Wait, yeah, 56, so that would be 60. And that's 8 plus 6 is 14. This is making me worry because I was expecting it to work. Oh, I multiplied by the wrong, oh my gosh, see, here's a chance for you guys to check my, it's not multiplying by 8, it's multiplying by 5. Oh my goodness. See, and I was expecting it to work when I tried to do it in my head early on, but it's because I multiplied by the wrong number, silly goose. Okay, let's try that again. 5 times 5 is 25. 7 times 5 is 35, 36, 37. 5 times 1 is 5, 6, 7, 8, 875, 2 decimal places, 875. Yes, that's a yes. See, that's what I was expecting in my head. Next one, if I buy, oh no, this is backwards. Look at this. I was even tempted. But this is saying I'm buying 17 and a half notebooks. Does that even make sense? How can we buy a half a notebook? I would spend $10? That doesn't make sense at all, does it? All right, how about this one? If I buy 9 notebooks, right, N is 9, would it cost $15.35? Well, again, I'm going to have to test this one out. $1.75 for 9 workbooks, or 9 notebooks. Let's see if that works. 9 times 5 is 45. 7 times 9 is 63. Plus 4 is 67. 9 plus 5 is 15. No, I got $15.75. And I got $15.35. Let me double check that math. 9 times 5 is 45. 9 times 7 is 63. 64, 65, 66, 67. Yep, 67. And then that's 9 plus 6 is 15. So it's close. But no, that would be $15.75. So no. The answers are those two right there. Very, very good. Last one, corn. A cornfield has an area of 28.6 acres. It requires 15 million. Wow, that's a lot. 15 million gallons of water. About how many gallons of water per acre is that? Now it says about how many, right? So this is an estimation problem. Do I actually have to divide this exact problem? No. So I'm going to estimate. If I have 28.6 acres, I'm going to round that up to 30 acres. That makes a lot more sense to me because I can go 30 into 15 million way easier, right? In fact, 30 goes into 150 5 times, right? And how many zeros would I have left? 1, 2, 3, 4, 5 zeros. So which answer is that? A 5 with 1, 2, 3, 4, 5 zeros? My guess is C. Now we can always double check that. 15 million divided by 30. Well, we know that's 5, which is 150. And then I would have to bring down. Again, this is where it gets redundant because I'd have to bring down all those zeros, and all those would be turned into zeros up here before I got to my decimal point. Oh, wait. Oh, yeah, that's a comma, not a decimal point. My decimal point is clear down here. So 1, 2, 3, 4, 5. I did actually an extra one. So it is 500,000 gallons of water per acre. The answer is C. Okay? Very, very good. That's the end of lesson 12's homework assignment. Well done, well done, well done. You are now ready and prepared for today's Check Your Understanding quiz. Go dive into that and see how you do. Of course, you can always redo those if needed, but you should be ready. If you've done your practice problems, you should be ready for this one today. So go dive into that. And as always, don't forget,
do your best because you deserve your best. Woo!